Hi students, before we talk about graphing functions, I wanted to show you my two dogs here. They're excited to meet you. This is Ginger. Ginger, give me five. Give me five. Good girl. And this is Zach. Zach, sit down. Give me five. No, give me five. Good boy. So those are my dogs. And this is what he does while I make videos. Okay, now that Zach is comfortable, we're going to learn a little bit about linear functions. And you probably are familiar with this from Algebra 1. But what we want to do is practice our XY chart, or as we're going to call our X and f of x chart. This symbol just means what is the function's value at x. So that's all it means. So if I were going to plug in, let's say, let's start with -1. We don't want to exclude the negative numbers. And I take this function at -1. All that means is take what you have, plug in -1 where you see x, and solve it. And that's it. All right, so that would be -2 plus 1, which is -1. So my y value, or my f of x value, f of -1 would be -1. And so let's go ahead and try 0 next. So if we plug 0 in for x, again we'll have f of 0 equals 2 times 0 plus 1, which is 1. So now my y value, or my f of 0, is 1. Okay, let's do one more. We want to try to get a good look of this graph, even though we're already kind of familiar with it anyway. So we're going to plug 1 in, and we have 2 times 1 plus 1. And you're probably asking, Miss Hunt, do I have to show all that work? Yeah. So this y value would be 3. So what we have here are 3 points. Now, this is, as you already know, this is a line, because it's a linear function. And it's going to have infinitely many points. All we're trying to do is grab enough points that we get the picture of what it looks like. So, but we know it's a line. So we're going to first start with plotting -1, 1. I'm sorry, wait, back that up. -1, -1, 0, 1, and 1, 3. See what happened there? I accidentally plotted the first point wrong, and I knew something had to be wrong. You always want to think of that as you're working, because you know this is supposed to be a line. So I'm doing this the best I can. It's not going to be beautiful, but there we go. And that is what a linear function looks like, and that should make sense. Okay, our next function we're going to talk about is the quadratic function. And this is one that we've been talking about in class a lot. Algebra 2 is, I'd say about 30% related around quadratic. So it's very important that you understand the skill we're going to do here. So what we want to do is, again, make our x and f of x functions, knowing that this stands for y. F of x just means what's the function's value at the particular x that I choose. So I'm going to start with, let's just start with something like 0. 0 is really easy. So I like to plug that in because this is just going to be 0 plus 0 minus 4. Well, 0 plus 0 minus 4 is -4. I didn't even have to show any work for that. So I like to start there. And we're going to go ahead and plot these as we go. So we're going to go to 0 and -4. And then we just want to start playing on either side and see what happens. So let's go positives. Positives are always easier. So we're going to do, we're going to do f of 1 is 1 squared plus 3 times 1 minus 4. That will be 1 squared is 1 plus 3 times 1 minus 4. 1 plus 3 is 4. 4 minus 4 is 0. So we'll just put that there. And so my next point will be the point 1, 0. Now what I want to see from here is, I know that this is some sort of parabola. So I just want to kind of see on the right of 1, is the numbers going to start going higher, or are they going to get lower? I don't know what's going to happen yet. So I'm just going to try, maybe we'll just try 2. That'll be easy. So we'll do, and you have to make these decisions as you go. So f of 2 would be 2 squared plus 3 times 2 minus 4. and that would be 4 plus 6 minus 4. 4 plus 6 is 10. 10 minus 4 is 6. Or you could look at it as the 4's cancel out and you're left with 6. So we're at the point 2, 6. Okay, so now I know enough about this parabola to know that it's just going to continue on into the positive. If I plug in 3, I'm going to get something larger than 6. If I plug in 4, I'm going to get something larger than that. It's just going to keep going. There's no sense in me continuing on that side. What I need to do is continue on the other side of 0. So I'm going to start looking at the negative numbers. So what happens at negative 1? For negative 1, we will have negative 1 squared plus 3 times negative 1 minus 4 is, now remember this is going to be a positive 1 minus 3 minus 4. 1 minus 3 is negative 4, is negative 2. Negative 2 minus 4 is negative 6. So we will be at negative 1, negative 6. Okay, so now we still need to know, we're going to investigate a little bit farther because we still don't have a parabola. If you look at our graph, there's still not a parabola. So let's go to negative 2. When I plug in negative 2, and I'll go through the same process that I did. So I would have, I'm just going to do this easy because I'm running out of space. Negative 2 squared would be 4. 3 times negative 2 is negative 6, and then minus 4 would give me 4 minus 6 is negative 2, minus 4 is negative 6 again. Wait a second, that's weird. So if I come over to negative 2, negative 6, then, oh, I see, that just means that this parabola is rounding here. This is where it rounds off. What happens is there's a vertex there, and that's something we're going to learn later in the course. But right now I just kind of know that it's going to keep going. So I could plug in negative 3 also. I kind of want to get a good idea of what's happening. So I might plug in another number, negative 3. I'm going to go ahead and tell you that when I plug in negative 3, I'm going to get out 1. Okay, I've already done the work for that. So negative 3, 1. 2, 3. That's not true. All right, I have to do it. I'm wrong. Okay, so let's do it. So f of negative 3 will be negative 3 squared is 9. 3 times negative 3 is negative 9, and then minus 4. 9 minus 9 is 0. 0 minus 4 is negative 4. Okay, so I lied. It's going to be at negative 3, negative 4. And that's why you want to always think about what you're doing. I mean, even I make the mistakes. But I can kind of see I have a parabola here. And since I know that it's symmetric, I can go ahead and start kind of drawing this picture in here. It's not going to be perfect, so we don't really know enough about this function yet, but that's what Algebra 2 does, is it makes us more precise once we start to learn these things. All right, and another function we like is the absolute value function. This one's pretty easy. We're going to go ahead and start again with 0. So I would have absolute value of 0 plus 2 would obviously be 2. Okay, no big deal. Let's go graph that. 0, 2. Okay, now let's try 1. When I plug in 1, absolute value of positive 1 plus 2 is 1 plus 2, which is 3. So I'm going to plot 1, 3. Now let's try something on the left-hand side. I can tell this is just increasing by 2, so no matter what I put in for x after 1, it's just going to get bigger and bigger and bigger. So I don't really need to do anything else on that side. So let's plug in negative 1. And in that case, I would have f of negative 1 is absolute value of negative 1 plus 2. The absolute value of negative 1 is positive 1, and 1 plus 2 would be 3 again. Okay, so I'm starting to kind of get an idea of what this graph looks like. I'm going to plot the point negative 1, 3, And what you may or may not know about absolute values is that it creates a v. That is what we call the parent function of the absolute value. It looks like a v, just like what you see here. Okay, and our last and final parent function we need to learn tonight is the square root function. This is one of my favorites. So we're going to plug in, use our f and f of x, and we'll see what happens here. What does this thing look like? So the only thing is that with square root of x, you want to plug in things that you know that you have a square root of. So my first question would be, do you think we can or should plug in a negative? Should we plug in negative numbers? Let's see what that would be. It would be like square root of, let's say, -1. Is that possible on this number line or on this number system? No. That's what you call undefined. So we're not going to worry about any negative numbers. So maybe we'll just start with 0 again. And in that function, at 0, I'd have square root of 0 minus 3, which is 0 minus 3 is -3. So I'm going to start my plotting at the point 0, -3. All right, now let's try. We know we can't do negative numbers, so let's do 1 and just kind of see what this thing looks like. So for f of 1, we would see square root of 1 minus 3. That would be 1 minus 3, which is -2. So now I have the point 1, -2. All right, I still don't know what this thing looks like, so I need to start throwing in some more numbers. So let's try 2, of course, naturally. No, I'm sorry, not 2. I don't want to use 2 because I'm thinking about it and I say, well, square root of 2, I don't know what square root of 2 is. So I'm going to try 4. I know what the square root of 4 is. So that's why I'm going to use that number. So I'm going to plug in 4. I'd have square root of 4 minus 3. Since I know the square root of 4 is 2, 2 minus 3 would be -1. So the point that I'm going to plot will be the point 4, -1. And so you kind of get the look of this graph now. It's going to start here at 0, -3, and it makes kind of like a swoosh like that. And that again is another parent function that you will learn in the course of Algebra 2.